Now that we know what we're building towards, let's go ahead and get right into it. Let's get our data from S3. So we're going to do this through DataBricks. Let's show the problem a bit more first, actually. So here we are on S3, which is where Mobile Analytics is writing to. AWS Mobile Analytics, or AWSMA. Events, and it's writing to 506E. Okay, so we've got our data in 2017, in October, on the 1st of October, at midnight on the 1st of October, and there's some analytics stuff that we've been capturing today. But this is all in JSON format. And if we look at the overall stuff that we've been doing for everything, how big are we? Probably not going to be very big. 159 kilobytes.
Baby size.
Yeah, baby size data. All right, but that's still a lot of individual files that we have to deal with.
Yes.
So what we can do is load all of this stuff into Spark and tell Spark to save it somewhere as a compressed format called Parquet. And Parquet is super duper freaking cool. You can get some pretty big compression ratios going on here. So this is Cloudera.
194 gigs.
194 gigs compressed to 4.7. So that's pretty cool.
Yeah.
That's pretty damn cool. So then not only does it take less space, it's then costing you less on S3 to store it. It's faster to query and load it because now you don't have to load so much.
For some reason.
Sorry?
For some reason.
Magic.
Yeah.
Magic. Yeah, and then it's got all kinds of cool benefits like making Athena super, super cheap for us to work with. So let's go back into Spark and let's attach ourselves to Mr. Me6, which is a cluster that we spun up offline a second ago. So now we've got a cluster. Let's just press run all because there's no troubles with that. This is going to get all of the data loaded off JSON and then cached onto the server. We're going to get all of it loaded from 25909. I thought we were working from 506E. Maybe we're not. Maybe we were working from 25909. More get size.
Just a little bit more.
This pretty much doesn't really matter.
Anyway, yep.
Then what we're going to do is we're going to come down to our queries down here where we're writing out our data. So just scroll to the very bottom, and these are all writing to our RDS server. Let's change these from write data to MySQL to write data to S3 as Parquet.
Yep.
So a bit more about Parquet while we're waiting for this thing here to load. How does it compress things? It stores everything into a columnar store format, which essentially says, let's go into Notepad. We can clear out some of these. I'll leave them out there. Doesn't really matter, does it? What? I don't need that one. What you can do with this is if you've got some columns, so column 1, column 2, column 3. Probably would have been better to do this in Excel.
Oh well. 1,
Richard, and 255. 2, Richard, and 355. You know, let's go 209, 260, and 3, Nick. What number would you like, Nick?
400.
400 flat. So what does Parquet do with this stuff here? It says, well, this is an int. And so it says, I can just make, instead of having to store the full number, it can remember that the next one is +1, the next one is +1, the next one is +1. Okay. So from an integer perspective, you go, that doesn't really help me. But then from an integer perspective on such small numbers, it doesn't really help me. But from column 2, we've got names in here. We've got strings. We've got Richard and Nick. If you instead say, every time you see Richard, let's just say that Richard is now known as
$1.
$1 is equal to Richard. So now we can save this as $1.
So it's like a pointer.
Yeah, pretty much. $1, and Nick can be $2.
Yep.
$2 is equal to Nick. So now as we save, millions and millions and millions of rows of this, we can say, awesome, why don't we just store $1 every single time and then go to look up the table as to what that actually means?
It's even better if you go, what if you say from here until here?
Yeah, exactly. Oh. So then, no, Nick is jumping ahead, which is freaking awesome to see. If we say this thing here, then we can say from column 1 to, from row 1 to row 7-ish, 8-ish. Parquet is accurate, I swear. Say all of these are actually column 1. Yeah. So then it has to say, remember it once, and then say replicate it 17 times. And it goes, all right, cool, I can do that. So now you've compressed it right down. And then this is where the integers can come in. The additional integer part can come in. It can say, awesome, instead of remembering 255 and 260, just remember that the next one is +5. And the next one is +140. So then it can just figure out everything as it needs to. And there's all different types of compression algorithms that you can have for different column types. You don't have to worry about them, just I wanted to give an overview of how it's working it. Okay. So how do we work with Parquet? We take our data from here, and then we, instead of, say, write to JDBC, are you doing a happy dance over there or something?
It's a happy dance.
It's a very happy dance?
Yes.
Cool. Keep dancing. This is happy topic. Nick is still dancing. Go Nick.
Go Nick. Go Nick. Go.
Go Nick. Go Nick. Instead of what we do is say, great, let's take that same query that gives us the data frame, and then we'll write it out as Parquet. We need to give it a path. What am I doing here? I am trying to go, let's take our data frame, let's write it. We're going to, I don't know why I switched them around because it needs to go the other way. We're going to overwrite whatever we have already got saved out. Then we are going to write it as Parquet. This is the format that we want to write it out as. Cool. And then all we have to do is say, great, where do you want to write this to?
S3 bucket.
So we want to write it to an S3 bucket, which we have already got A1 created. A1? We already have one created from here. So let's just make another cell up here, and we'll call it df. It's not even df, we'll call it path Parquet output, or output Parquet. And this is going to be pointing to this bucket. Mount Analytics data, which is pointing to our S3 bucket of AWS Unity Analytics. And let's just stick it straight here, call it Parquet. Parquet / that's it. So I'll just run this guy so it gets saved or populated. That's a better word for it. Come back down to where we were writing out as Parquet. And now in here where I was writing it, just put that. And clean this up. Now, the only thing is that if we look at this file here, it's going, well, let's demonstrate that first. Run it. So this is going to go ahead and query our JSON data, load up JSON data, perform this query over the top of our JSON data, and then write it out as Parquet. Cool. So waiting for that one to finish. Let's come back into S3 as soon as it finishes. So exciting. It's going to do that, like hit the end and then do a bit more. Hey, there we go, it worked. So we'll come in here and we will refresh this. Go gadget S3 bucket. Bang. There it is. We now have a folder called Parquet. And inside of this, we look at it all, but it's got each of the individual JSON files. Well, okay, so it has loaded each of the individual JSON files up, and from each of them picked the necessary information to populate the JSON, the data frame that it had. So if there was 50 JSON files and it had to read a bit from all those 50 JSON files, it is then saving out 50 Parquet files, which is not helping us. So what we can do is go, you know what, I actually want all of these compressed into one instead of lots of individual files. So we go, cool, let's just change this to .repartition 1. What? So take all of the individual files that you've got that make up this data frame and combine them into one single file.
What if you put it in 0? Singularity?
I have not tried putting 0, but it wouldn't quite make sense to put it as 0. Because if you repartition to nothing, then it would give you nothing. Or it will give you a divide by 0 issue error. It wouldn't give you a divide by 0 issue error. Anyway, let's just go with 1.
Let's go with 1.
And because this is set to write and then saying overwrite, it will say, cool, whatever data you already have in that folder, I am going to destroy it.
Get rid of it.
And then I will put new stuff in there.
I like new stuff.
I like new stuff too. But it can have the problem of if it's just written a whole bunch of stuff out and then you accidentally press overwrite. Oh darn, you've gotten rid of all your files and you only have the new stuff available to you. Alright, so that's finished. Let's come back into S3 and we'll press Control F5 to refresh this folder and see how many files you got now.
1.
1! It does actually only have 1. Well, it's okay. So there's the success file that says, hooray, I successfully have finished. There is the started file that says, I am beginning to write these files out. There's the completed file that has a bit of metadata to say how long it took and how many it finished and blah, 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 and what files were involved in that writing process. But we've combined all of that stuff down to 4.8K.
Wait, what? Oh, wait, from 2? No.
Remember before it was lots of little files?
Yeah.
Some of them were 1K,
right,
some
yeah.
of them 3K, some of that.
Oh, true.
Because we've got a whole bunch of... How many level 1s do we have in there?
Oh.
So it said, well, why would I store level 1, level 1, level 1, level 1, level 1, level 1?
Why would it do that in the first place?
Why would it do what?
Why would it do so many things in the first place?
How do you mean?
Like, what? If this is more efficient, I wonder why it did it, like, split out to, like, hundreds of them.
Oh, because we didn't tell it to combine them into one.
Yeah, but, like, why would it do it by default?
Because that's the way it was loaded as individual partition files.
Oh, I see. Because for each of the actual S3 objects.
Yep. Remember?
Oh,
every hour of analytics, it wrote another one
Okay,
file.
that makes sense. Okay, all right, cool. I get it.
Sorry, I didn't realize I didn't explain that part out very well.
No, cool. That's I got it now.
Cool. So now we've got another problem, which is, hang on, we've just put player path by clicks in this folder. And if we put the player path by time and by distance in there, then we're going to have a lot of other problems. So let's just quickly change our
Parquet
our file. I'm just going to put this guy back up the very top. Come on, scrolling. Let's scroll to the top. So we can now put path output Parquet by clicks. Parquet / path by clicks. Let's see, time, distance, player spotted.
So, by distance, player spotted.
La, 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 la. Okay, cool, there we go. So now we've got a folder for our clicks, a folder for our time, a folder for our distance, and a folder for our player spotted. So if we take, whoops, I meant to do copy on that, not collapse. Not cut. Cut's what I meant to say. So now if we write this one out to player path by clicks, and we can take this one, what's your problem?
What?
Write.save mode path. Oh, I forgot to actually run it. Run it.
That's cool. It didn't used to do that.
What?
DataBricks?
No, I didn't. It just started, that probably the past month or two started telling you that.
That's really cool. I like that.
It is very handy. For like, it even tells you if you go run all and then it runs into a problem with the cell, it says this cell was the one that had the problem.
Oh, that's cool.
And you can scroll away and it'll tell you what's running. Anyway, sorry, I've been doing some other stuff.
Now we just need IntelliSense.
IntelliSense will be fantastic. All right, so let's put the next one in, which is player path by time. It's copying in the data frame. Overwrite to player path by time. Then we need another one for distance. Whoops. Going to grab the data frame for distance and stick it in and say data frame, repartition yourself, write it out to the by distance folder.
Cool.
And the last one will be the df player spotted. Write yourself out to the player spotted folder, which is then going to need to be the df, the data frame for that, the doof. Run that. Now, you don't have to overwrite. You can also just change this to append. And it would go, cool, whatever data you've got, I'll leave that in there, and I'll just insert this stuff over the top.
So that's good for when you want to delete the original data set.
Yep. Or move it to another folder so you can keep the originals. Overwrite. Cool. So now we come back into our S3 bucket. We'll press Shift F5 to refresh it.
Oh, right. Yeah, cool. It's a folder.
So there we go. So now we've got clicks, distance, time, player spotted, and we don't need these guys because they were by clicks, but now they're in a folder. Cool. We'll get rid of that. Delete it. And now we have them all saved as Parquet.
I like that. Oh, that's very cool.
It is very, very simple. Spark is super duper cool with what it can do. So that is all we're going to do in this video. In the next video, we are going to take a look at Athena.
Yes.
Actually, I think we will first off have to create an IAM role that can talk to Athena on our behalf. And then we will get to working on Athena.
Cool.
So all right. That's it.
All right. See you guys later.
Bye-bye.